Wireshark is a complicated tool, right? So in this video, I'm gonna simplify Wireshark for absolute beginners. So guys, if you are, someone who is new to Wireshark or struggling with it, then trust me, by the end of this video, you will be able to use Wireshark efficiently and you will end up thanking me, hopefully. So make sure that you watch the complete video. And I do have an advanced course on Wireshark, which is there on Udemy. So feel free to check that out as well. Again, this video is more than enough to get you started with Wireshark. Alright, so let me walk you through the course video contents, what you are gonna learn in this particular video. We will start with the basics, of course, what Wireshark is and its use cases. Then we will learn how to select the correct network interface to start capturing packets. Then we will move to the toolbar and all its functions. Then we will understand its overwhelming interface and all other essential core components. And we will wrap up this video with filters, and we are gonna cover both capture and display filters. Wireshark is a special tool used for monitoring computer networks. Wireshark helps you to see what is happening when your computer sends and receives data. It monitors or captures all the network traffic. Wireshark is of course free and open source tool. Wireshark is a must-know tool for security analysis. It is often used to detect and analyze network security threats such as hacking attempts, unauthorized access to sensitive data, and it can easily identify attacks or suspicious traffic on your network. It is a go-to tool for cybersecurity analysts. Wireshark can be used to analyze network traffic in real time to identify and resolve network related problems such as slow performance, dropped packets, and other connectivity related issues as well. Developers can use Wireshark to understand how protocols work and identify issues related to their implementation. These are just the main uses of Wireshark. It is a very vast tool. It can be used for many other things. Now, to download and install Wireshark, go to the wireshark.org, click on download. Here we have files for Linux, Mac, and Windows. So download the appropriate file according to your operating system. Here, as you can see, guys, we do not have files for 32-bit systems, right? This is because Wireshark 4.0 or higher versions do not support 32-bit systems, right? So if you have an older computer or 32-bit system, then you have to download this file 3.6.11. So click on this down arrow. From here you can download 32-bit file for your operating system. And I'm not gonna go through the installation steps because installation process is very simple on all operating systems. On Windows, make sure that you do not check or uncheck anything during the installation, right? Keep clicking on next, then your installation will be successful. If you come up with any problems during the installation or any part of the video, then let me know in the comment section and I will happily answer everything. Alright, so once your installation is complete, then open your Wireshark. And this is the welcome window of Wireshark. It displays all the installed network interface cards, and this list is going to be different for everyone. Most likely you are not gonna see all these local area connections because they are not real or physical cards. They are created by my virtual machines. Now, there are two inbuilt network cards on each system, Ethernet and wireless card. Ethernet is simply represented by Ethernet on Windows, and wireless card is represented by Wi-Fi, and on Linux the wireless card is represented by WLAN 0 and Ethernet is represented by ETH0 on most Linux distributions. Now, to start capturing packets, you have to select one of these physical network cards. Now, which one exactly you have to select? Well, it depends on your connectivity, how you are connected to your network, or how you are accessing the internet. I'm connected to my network through Wi-Fi or wireless card, so I'm gonna select Wi-Fi. As you can see, it is showing some spikes, right? These spikes are indicating that there are some activities going on this particular interface. We also have spikes on adapter for loopback traffic interface as well. Well, this is the local host. It does not capture your network's traffic. It only monitors your system traffic. This is not that important. Again guys, I'm gonna select Wi-Fi to start capturing packets. So double click on the appropriate interface. As you can see, Wireshark is capturing packets, right? At the top you can see capturing from Wi-Fi, right? Now, first thing that I'm gonna do is explain what all these different sections or components mean, what information they represent. So go to the view menu. Allows us to control the components that you want to appear in your display area. As you can see, Wireshark has already pre-selected some of the components for us. First three selected components are main toolbar, filter toolbar, and status bar. This is the main toolbar. It contains the functions that you are gonna use on a regular basis. I will get back to all these functions later in the video. Then we have filter bar. This is the filter toolbar. Here you can type your filters. Filters are basically used to hide unnecessary traffic. I will get back to filters later as well. For now, just remember that if you want to type and apply the filters, then this is the place where you can type the filters. Then we have a status bar at the bottom. This is the status bar. As you can see, it basically gives you a brief summary of captured or lost packets. Then we have packet list. This section is called packet list. Packet list displays or contains all the captured packets. Every single packet that Wireshark captures is going to be displayed or listed here. Then we have packet details. As you can see guys, the packet list section only gives you a brief overview of each captured packet. Now, if you want to analyze packets in detail, then you can use packet details section. For example, let me stop the session first. I'm gonna click on packet number 139. Now, down here, packet details section is displaying a detailed information about the selected packet. As you can see, frame number 139. Now, here you can analyze the selected packet in detail. Now let me click on different packets. As you can see, the information keeps changing as I click on different packets. Then we have packet bytes. On your right side, this section or panel is called packet bytes. It displays information in its raw or original form. Right, as you can see, the default format is hexadecimal, and you can also change it to binary. So click on the blank space, click on as bits. Now as you can see, information is in raw binary. I'm gonna revert back to the hexadecimal format because it is a little more presentable than binary. And if your packet contains plain textual information, then that information will also be displayed here as it is in its raw form. Now go to the view. Let's say you do not want packet bytes section, then click on this packet bytes or whatever you want to hide. Now as you can see, it has been completely hidden. So to get it back, go to the view, again click on packet bytes. Now it is back here. Now let me walk you through what all these columns mean, right? So first column that we have is NO. NO is short for number. It basically displays the packet number. Each packet is going to have a unique number. As you can see, the first packet that Wireshark captures is automatically assigned number 1, second packet 2, and so on. Then second column is time. Time column displays the exact time when a packet was captured. Right now the default format for displaying time is not that presentable, right? So let's change it first. So go to the view. Now click on time display format. From first half, select time of the day. Again go to the view, time display format. From lower half, select seconds. Now as you can see, we have a much better or presentable format for displaying the timing of captured packets. Then we have source. Now source column displays the IP address of sender who has sent the packet. Destination column displays the IP address of receiver where the packet has been delivered. So let me select, let's say, packet number 30. Sender of the packet number 30 is this IP address 192.68, and it has delivered this packet to this device 35.3. Then protocol column displays the packet type, whether it is TCP, ICMP or UDP packet. Length column displays size of each packet in bytes. Info column, it gives you a brief overview of each captured packet. So that's what all these columns mean. Now let's go through all the toolbar functions. Red button stops the current running session, and first button from left starts a new session. So click on it. As you can see, before starting a new session, Wireshark is asking me whether you want to save already captured packets. So I'm gonna click on save, then give it a file name, let's say packets. Now you don't have to write any extension after the file name. Remember, Wireshark automatically saves your packets with .pcap or pcapng extension. Pcapng is the default extension for saving Wireshark files. Click on save. Now a new session has been started. Then third button restarts a new session. So if you want to restart a new session when you already have a session running, then click on this button. And here also, if you want to save already captured packets, then click on save before continuing. This time I'm gonna go with continue without saving. Then fourth button is capture options. Capture options button cannot be accessed when you have a session running. So let me stop the session first. Now if I click on the capture option button, as you can see, now it is working. Now capture options window displays all the network interface cards, just like your welcome window. The only difference is that it gives you a much better control over interfaces. As you can see, we have additional options such as promiscuous mode and monitor mode. Okay, I will get back to capture options later. Then we have open a capture file button. So this button allows you to open a already saved file. So click on it. Now I'm gonna double click on the file that I saved a few seconds ago. So double click on the file. Now continue without saving. Now as you can see at the top, packets.pcapng, Wireshark is reading packets from this particular file. Then next button that we have is save this capture file. So this button basically gives you option to save your packets quickly. So click on the button, write the file name, then click on save. It will save the packets. Now another way to save packets is go to the file, click on save as, then next button is close. So close button takes you back to your welcome window, as you can see. So let me start the session again. Now next button that we have is find. So click on the button. It basically allows us to search for packets based on different types of values. As you can see, we have a drop down menu here. So click on the down arrow and let me start with, let's say, string. Now in this box, type a string or text, let's say payload. Now let me click on find. As you can see guys, it is highlighting the packet that contains the word payload right here, as you can see. So when you select the string option, whatever you type here, Wireshark is gonna search for that particular text or string in each packet. Wherever it finds the word payload, then it will highlight those packets. As you can see, for now it is highlighting packet number 55. Now if I click on find, it is highlighting the next packet that contains the word payload, like this. Then we have hex value option. Let me select it. Now here you can search by hexadecimal values as well. So let's say 4A. Now click on find. As you can see on the packet bytes panel, 4A is highlighted, and in the packet list section, Wireshark is highlighting the exact packet that contains this value. Then we have a display filter. We have not covered the display filters yet, right? Once you will learn display filters, then you will automatically learn to use this feature. For now, you don't have to worry about it. Then next two buttons that we have are right and left arrow. So right arrow button basically takes you one packet up from your current position. My current position is, let me click on 8. So if I click on left arrow button, it will take you one packet up, and right button is gonna take me one packet down from my current position. Then we have go to specified packet. Click on the button. Here in the box, type the packet number, let's say 5, and click on go to packet. Then as you can see, it has taken me to the packet number 5. It is being highlighted. So whatever number you type in here in this box, Wireshark will take you to that particular packet. Then we have up and down arrow keys. The up arrow key is gonna take you to the first captured packet in the list. Click on it. As you can see, it is highlighting the first packet in the list, and down arrow key takes you to the last captured packet, right? Next button that we have is this automatically scroll to the last packet during live capture. So when you enable this button, it will automatically take you to the last packet that Wireshark captures during the live session. As you can see, it has this light blue background color, right? It means it is enabled, right? If I click on it, now it is disabled. It is advised that always keep it enabled. Now the next button basically enables the packet coloring. As you can see, we have packets with different colors, right? TCP packets have a different color, and ARP packets have a different color. So what basically Wireshark does, it assigns a unique color to most commonly used protocols or filters, so we can easily identify the packets, right? So when I'm gonna see this light pink color, I can automatically recognize, yeah, this is an ARP packet. Now if you want to find out which color is associated with which filter or protocol, then go to the view, click on coloring tools. Now here you can basically see which color is associated with which filter or protocol. UDP protocol is going to have this light gray background color, so feel free to go through the list. You can even customize these colors. Let's say for ARP you want a different color, so click on the ARP, then down here click on background, then select a color of your choice, then click on OK, and after that click on OK. Then color will be changed. In the same way, you can change foreground or text color as well. Select the color, click on OK, then click on OK. Changes will be applied right away. Then next buttons that we have are plus and minus. Plus button basically is used to increase the font size, as you can see, and minus button is for decreasing the font size, and button next to minus button sets the font size to default. If I click on it, as you can see, the font size has been set to the default. Now the last button resize or sets the packet columns size to default. As you can see, my destination column is overlapping the source column, right? Now if I click on this last button, as you can see, the size has been set to the default. Now I can see contents of each column easily. Filters are used to hide or filter out unnecessary traffic. For example, here as you can see, I have thousands of packets, right? Now let's say I only want to see HTTP packets in my packet list section. All other traffic is irrelevant or useless to me. In that case, if I manually try to locate every single HTTP packet among thousands of packets, then it is going to take a lot of time, right? So to solve this problem, we have something called filters. Filters allow us to exactly see what you want to analyze and see in your packet list section. For example, I only want to see HTTP packets. Then all I have to do is type a valid HTTP filter. Then Wireshark is only gonna show all the HTTP packets and other traffic will be hidden. So this is as simple as that. We have two types of filters in Wireshark: display and capture filters. Display filters are used or applied on already captured traffic. As you can see, I already have captured packets. Here I can apply the display filters, and I will get back to capture filters later. Now let's do some practical examples of display filters. Display filters can be written and applied here in the display filter bar. So I'm gonna start with filtering HTTP traffic. So traffic filter for filtering HTTP traffic is just HTTP. So type HTTP. As you can notice, when you type a correct or valid filter, Wireshark automatically changes background color to green. Green background means a valid filter. Now if I type something that Wireshark does not recognize, then background color changes to pink. So green means valid, pink means invalid filter. Now how to apply the filter? We have two options. First, press enter. Now as you can see, filter has been applied. Under the protocol column, Wireshark is only displaying the HTTP traffic, because this is exactly what I have told Wireshark. Only show me HTTP traffic. Now another way to apply filters is click on this right arrow on your right side. Click on it, then filter will be applied. You can clear filters by clicking on this cross button. Now as you can see, we are back to the normal. Now let's filter, let's say, DNS packets. So filter for that is DNS. Hit enter. Now as you can see, Wireshark is only displaying the DNS packets. Now I want to see, let's say, TCP packets only. So filter is TCP. As you can see, it is only showing the TCP traffic. In the same way, let's say I want to see UDP packets. So filter for that is UDP. Now let me see whether I have any ARP packets. So type the ARP, hit enter, and yeah, this is the ARP filter for filtering ARP packets. In the same way, you can filter all the possible network traffic. All you have to do is remember the protocol name, then type that in here in the filter bar. Now let's filter encrypted or HTTPS traffic. Your first guess might be HTTPS, right? As you can see, this is not a valid filter, right? So to filter secure or HTTPS traffic, then you have to type TLS. So press enter, as you can see, now Wireshark is showing all the encrypted traffic. TLS filter makes sense because HTTPS protocol is actually combination of HTTP and TLS. TLS takes the HTTP traffic, then encrypts it, and that makes the HTTPS protocol. Sorry, I forgot to add S. Now, till now we have used or filtered one type of traffic only, right? Now let's say I want to see ARP and DNS packets simultaneously. It can be done through something called operators or operator. So type DNS, then write OR and ARP. OR operator is used to combine multiple filters. So here I am basically telling Wireshark, if you find DNS packets or ARP packets, then show me all those packets. So if I hit enter, then Wireshark, as you can see, it is displaying all the DNS and ARP packets. In this way you can combine as many filters as you like. So let me add another filter, TLS or ICMP. Okay, so feel free to add as many filters as you like. And OR operator can be written with two pipes as well, like this. UDP, this is also a valid filter, or ARP. See guys, the OR operator pretty much works as it works with programming languages. So here it can be used to combine multiple filters. Now let's use NOT operator. So type NOT and TCP. Now what does it mean? NOT operator basically negates the value that you supply to it. Here I'm telling NOT operator that okay, don't show me TCP packets, show me everything but not the TCP packets. So if I hit enter, you are not gonna see any single TCP packets in the list, as you can see. And NOT operator can be written with exclamation symbol as well. So exclamation TCP, it is also a valid filter. Now let's filter traffic by port numbers. So type let's say TCP. I want to filter traffic on port number let's say 80 port is for HTTP, right? So if I hit enter, it is not a valid filter. Sorry, I forgot to add equal to signs. So port number 80 means it is going to list all the HTTP traffic. Here also you can use OR operator, or TCP dot port EQ means equal to 443. So EQ or equal to sign, both are same. So if you hit enter, now this time I'm telling Wireshark, if you find HTTPS or HTTP traffic, then list all those packets. So 443 port number is obviously for secure or HTTPS traffic. Now let's cover another very important filter called IP adder. IP adder filter is basically used for filtering traffic by IP addresses. Let's say you want to check all the packets that a particular IP address has sent or received. So write IP.adder equal to, then paste the IP address. Now this filter is gonna only display the packets that this particular IP address has sent or received. So if I hit enter, now as you can see under the source and destination column, right, you can use OR operator to combine multiple IP addresses. So let's say you want to check packets that multiple IP addresses have sent or received, then use OR operator IP.adder, let's say here 79. Now this filter is gonna display all the packets that these two IP addresses have sent or received. In this way you can combine as many filters as you IP addresses as you like. Now here also we can use NOT operator. So if I type NOT at the beginning, then what I'm telling Wireshark this time is do not show me packets that this particular IP address has sent or received. So if I hit enter, you are not gonna see this IP address in the packet list, as you can see, because we have clearly told Wireshark don't show me packets that have been sent or received by this IP address. And another important filter that I'm gonna teach you is contains. So type TCP, let's say contains. Now within the double quotes, write YouTube. Now what this filter is gonna do, it will check every single packet in the list and see whether the packets contain the word YouTube. If any packet contains YouTube, then that packet will be listed here. If I hit enter, and as you can see, there are no such packets that contain YouTube. Now let's try the DNS. Now as you can see, we do have DNS packets that contain YouTube. So as you can see, youtube.com. So this IP address visited this website YouTube, or it basically made DNS queries to youtube.com, right? Now let's move to the capture filters. Now capture filters allow you to have control over your traffic, what you want to capture. Capture filter, as the name suggests, you can basically tell Wireshark before starting a new session what you want to capture, right? By default, Wireshark captures all types of traffic floating on your network. Now let's say you only want to capture HTTP traffic, right? You don't want to capture any other traffic, just FTP or HTTP. Then you can tell it to Wireshark before starting a new session. Then Wireshark will only capture whatever traffic you tell it to capture. So you have to go back to your welcome window. Now first thing that you have to do is select the interface where you want to capture the traffic. Then here, as you can see, we have the box where you can type the capture filter. Capture filters are different in terms of syntax from display filter. So if I type, let's say HTTP, then as you can see, it is not a valid filter, right? So to write a filter to capture HTTP traffic, then we have to write port, then port number 80. So port for HTTP is 80. So this filter is gonna capture the HTTP or traffic on port 80. Now to start capturing packets, double click on the interface. Now as you can see guys, at the top, capturing from Wi-Fi on port number 80. So it is only gonna capture traffic on 80. So let me visit, let's say this is an HTTP website, as you can see, not secure. It is capturing HTTP traffic. Now let me visit a website which uses HTTPS, let's say YouTube. As you can see, it is not capturing anything, right? So to confirm it further, let me apply the TLS filter. As you can see, TLS found nothing, because this filter, capture filter, is only gonna capture the HTTP traffic. Now back to the welcome window again. Another place where you can type the capture filters is go to the capture options. Now here, select the interface first, then write the filter. Here, as you can see, at the bottom we have a box. So port number 80. Now let's say I want to capture FTP traffic, then you have to write the port number for FTP, which is 21. Here also you can use OR operator. So type port, now let's say 22. Now this time Wireshark is gonna capture both HTTP and SSH and FTP traffic. You can combine as many filters as you like here. And if you click on start, then it will start capturing traffic. Now if you want to capture, let's say, only TCP traffic, then you can directly write TCP. TCP and UDP filters are common for both. display and capture filters, right? Let's say UDP. Now let's say you only want to capture traffic that a particular IP address sends or receives. Then write the host filter, then paste the IP address. Now this filter is only gonna capture the traffic that this specified IP address sends or receives. So guys, that is it for filters. If you want to learn more about filters, then feel free to check my Udemy course, where I have covered a plenty of advanced filters.